Welcome to the Renewable Energy Study Group. In the today's session, we're going to talk about some points regarding the manufacturing of a solar cell. How actually the solar cell is getting manufactured in the industry. One by one process we're going to see in this session. First, whenever the silicon cell or the solar cell is getting manufactured, the base material that we are using for manufacturing is the silicon material we are using. Basically, typically in the earth crust, the silicon is been available in the abundant format and it is been available in the form of a sand actually. We have to convert this silicon dioxide sand into the pure form of the silicon, and then we can utilize the silicon material in the manufacturing of a solar cell. Basically, whenever we are doing the manufacturing of a solar cell, the first step comes as a charging of the silicon sand. So whatever the silicon rock or silicon sand we are taking, actually we have to put this particular silicon sand into the quartz crucible. Quartz crucible is a pot like a structure in which it can sustain the higher amount of a temperature where we are keeping this sand actually. We want to melt this particular sand at the higher temperature. Once this sand has been melted actually, then we convert this particular sand into the pure form of a silicon. That is why we have to put this particular polysilicon rocks into the quartz crucible, that is a high temperature sustaining pot actually, and this pot we need to keep in the furnace over here. At the very high temperature, this sand is getting melted, and in this particular melted form of the silicon actually we have to add the boron material over here. Because as we know, whenever we want to construct the silicon cell or the solar cell actually, it has been made up of the two type of material. One is the P type of semiconductor, other is the N type of the semiconductor. So that is why whenever we need to construct the lower layer of the silicon cell, it has been made up of the P type of the semiconductor material, and to make the P type of semiconductor material basically we required boron, which is the acceptor impurity we are taking over here. Over his outer shell actually there are total 3 electrons are present, and by accepting the 1 electron it will form a stable bond or stable covalent bond with the silicon material actually. So that is why in the first step itself, whatever the material we are preparing, it is a P type of the semiconductor material we are preparing just by adding the small amount of the boron impurity inside this particular quartz crucible. So in this silicon where it is melted actually, in that we are putting the boron material, and this boron material is also getting melted and it has been just circulated inside this particular melted form of the silicon actually. And with this addition of a boron, we were preparing actually the P type of the semiconductor material, which is a base layer for the silicon cell or the solar cell. Once the charging process has been happened at a very high degree of temperature, let's say 2500 degree Fahrenheit temperature, then the parameter comes to add the particular wire or the seeding material inside this melted form of the silicon actually. In this particular wire actually we are putting the particular seed of the silicon structure, and this particular wire we are dipping inside the melted form of the silicon over here. So whatever the quartz crystal or the quartz crucible, that is a pot we are taking, this pot is moving in the clockwise direction, and this particular wire having the seed of the silicon is moving in the anti-clockwise direction. And side by side this melted form of the silicon is getting deposited over the silicon seed material, that is the over the wire actually. This particular melted form of the silicon is getting deposited one by one over here. Slowly the pot is getting rotated in the clockwise direction, the wire is getting rotated in the anti-clockwise direction, and side by side this particular melted form of the silicon is getting deposited over this particular wire actually. Once this particular melted form of a silicon is start getting deposited over this wire, then we allow this particular bar of the silicon actually to for a subsequent cooling purpose over here, because at this moment the temperature of this solid silicon is also very high, and we need to keep this particular silicon bar for the cooling purposes over here. So basically in the cooling actually the time required is 3.5 days is required for cool this particular bar, and we are cooling this particular silicon bar at a high temperature, let's say 300 degree Fahrenheit. We allow him to cool over here actually. So in this particular temperature, the whatever the homogeneous layer has been formed inside this particular silicon bar over here, and ultimately we are getting the solid crystal structure of the silicon over here in the cooling process. Once the cooling process has been happened, then there is a cutting process will be there. So the top of the portion and the bottom of the portion, we just cutting from these actually, and this bar we are cutting in the length of the 2 feet length we are cutting over here. So once all this bar actually it has been cutted in the form of the 2 feet length, likewise with the help of the wire saw machine or the saw machine that we are taking over here. So after the cutting process has been over, then we have to do the squaring of this particular bar that we have taken, because bar size is actually it is in the cylindrical direction, or it is basically in the cylindrical side is there actually. With the help of the wire slicing machine, we are squaring this particular bar over here. At a time the 16 number of this bar actually we can cut at a time in the same number of a time. So there is a spherical form of a structure will be appeared after this squaring process over here. The length of the individual bar will be the 2 feet is there, and with the help of the wire slicing machine we are squaring this particular bar over here. Once the squaring process has been happen over here, then the next process is to slicing of this particular wafer over here. As we know, the wafer thickness of the silicon actually it is 200 up to the 500 micrometer, so it is very thin actually when we see compared to the thickness to the other parameter actually. So that is why the fine slicing machine we required over here. So we use the wire slicing machine. So with this slicing machine actually we were preparing the thickness of this particular wafer up to the 1 mm or up to the 2 mm over here, and after that also we are making the wafer of 200 up to the 500 micrometer of these individual silicon wafer over here. So for that purpose we are keeping this particular bar inside this particular cylindrical drum over here, and then we can do a slicing of this particular wafer at a thickness of 200 up to the 500 micrometers. After the slicing process has been over, then the next process is called as the texturing process. So basically in the texturing process what we have doing over here, the front surface of this particular silicon structure we are etching the outer part of this particular silicon wafer. And the reason for this particular texturing and the etching process is that whenever to reduce the basic optical losses that can be occurred for the silicon actually, because whenever light is falling over this particular silicon cell, if it is a very flat type of the silicon cell is there, it is getting reflected from this cell over here. So that is why the small pyramidal type of a shape we are doing over here. So it is called as the etching surface of this particular thing, or the texturing process in the silicon wafer over here. Once the texturing process has been over, the next process is the diffusion of the phosphorus gas over here. So basically at some higher temperature we are diffusing or we are passing the phosphorus gas over the frontal part of the wafer actually. And the main reason is that whenever we are adding this phosphorus material over the front part of the silicon cell, so actually we are adding the acceptor impurity over here. Because of phosphorus we can say it is an N type of the material is been added over here, we can say. In the outer shell of this particular phosphorus element actually there are 5 electrons are present, and by donating the 1 electron to the acceptor impurity, and this particular impurity which is a donor impurity is there actually, so that is why it has been fixed over this particular solar cell. So the upper part of a solar cell is having this particular phosphorus material, and the lower part is having the boron type of material, and this phosphorus and boron is called as the impurities that we are adding to convert the pure form of a silicon into the P and the N type of the semiconductor over here. So that is why we need to pass this particular phosphorus gas at a higher temperature over this particular silicon structure or the silicon wafer over here. And this ultimately at this process we can say our solar cell or the silicon wafer has been converted into the P and the N type of a junction for this particular case. So in this case the pure form of a silicon is been converted into the PN junction over here. Once the diffusion process has been happened, then it is required to coat over here. So basically when we look at the solar cell actually, it will look like some purple or some bluish type of a color it will be looking like actually. It is because of the layer of the silicon nitride that we are passing over this particular silicon layer over here. So basically, to give this particular silicon cell to the proper coloring type, we require the silicon nitride to be passed over this particular solar cell, and the color of this gray colored solar cell is been converted into the bluish purple type of a color over here. The next reason to allow this particular bluish purple color, or just give this particular bluish purple color with the help of the silicon nitride coating, it is also called as the anti-reflective coating over here. So whatever the blue, that is a blue high energy photon which is coming from the sunlight, actually it is been absorbed by this particular layer over here. Silicon nitride layer is also called as the anti-reflective coating, and the reason behind the giving anti-reflective coating is to avoid the recombination losses and the optical losses, because they can reduce the power output from the solar panel over here. Once the coating process has been happened over here, then the last step is the printing of the fingers and the bus bar. So when we see with the help of a naked eye, actually that time we see number of horizontal lines are there, which is called as the fingers, and the number of vertical lines are there, which is called as the bus bars over here. So whenever the light is getting exposed actually over this particular solar cell, whichever the electron holes pairs are getting generated, and whichever the flow of an electron is getting generated, actually it has been captured by the individual finger, and further power is been given, or the current is been given to the central bus bar over here. Central bus bar are the vertical number of a line. This count will be vary actually, that is 2 number of bus bar, 3 number up to the 5 number of a bus bar. We can change this particular printing over here. So as per the number of bus bars are more in the system, actually we can collect the more amount of the electron and the holes from this particular solar cell over here, and from that we can collect the power at a central level, and we can utilize this power for the subsequent application for that. So that is the last step in the printing process over here. So generally the silicon wafer or the silicon cell has been made up from the basic silicon material. Further, this silicon material is kept into the quartz crucible at a higher temperature, and the boron impurity has been added, that is a P type of impurity we are adding over here. Again, after this dopant type of this impurity, we are getting the solid bar of a silicon by dipping this particular wire frame inside this metal form of the silicon. Then once we have get this bar of a silicon, actually we were cutting into the 2 feet length over here, and again it has been sliced down into the 200 up to the 500 micrometer thickness at this wafer over here. Again this wafer has been etched by this etching process with a surface texturing. Then it has been passed through the phosphorus gas. So the upper layer is been added with the phosphorus type of the impurity, which is the N type of a impurity. So here actually we get the PN junction diode over here, and again after this addition of impurity, we are coating with the anti-reflective coating, that is ARC coating of silicon nitride, to give the color up to the bluish color or the purple color, and to avoid the optical and the recombination losses over here. In the last step, we are doing the printing over here. Printing of the fingers and bus bars allows us to collect the current which is being generated inside this PN junction or this particular silicon cell. Thank you for watching the video. Share this video to your friends also. They also let knowledge of this solar energy actually. Thank you for watching.